Hello there. In this video, we are going to see how to convert the Bernoulli's equation to linear ordinary differential equation by taking just one example here. First of all, let's have general idea about Bernoulli's equation. The differential equation of the form y derivative plus p of x y is equal to q of x y the power of n. We call it Bernoulli's equation. But if the n is equal to 0, if this n is 0, the Bernoulli's equation will be immediately changed to linear equation. It's going to be y derivative plus p of x y is equal to q of x. This is linear ordinary differential equation. But if n is equal to 1, again it can be changed and written as linear ordinary differential equation or linear Bernoulli's equation. It's going to be y derivative plus p of x minus q of x y is equal to 0. We can write it. If n equal to 1, this is going to be 1. So y term we left here also. So we can collect and write in the form y derivative plus p of x minus q of x the whole times y equal to 0 for. Still, this is linear equation. But if n is different from 0 and n is different from 1, we can change the given Bernoulli's equation to linear ordinary differential equation by multiplying each term by y the power of negative n. Each term multiply. What does that mean? It's going to be this. The first term is going to be y the power of negative n y derivative plus p of x times y the power of negative n plus 1. This exponent is 1. So when you multiply, the exponent will be added because the base are the same. So 1 plus negative n will be 1 minus n is equal to the right side, just only q of x will be left. Then we can take this one as u. U is equal to y the power of 1 minus n. Then when you derive both sides, the u derivative will be, when you derive this one, the exponent will come. It's going to be 1 minus n, the whole the power of y. We are going to reduce the exponent by 1. So when you reduce, the 1 will be removed and negative n will left. Times y derivative by chain rule. We need to derive the y also. Therefore, we can divide both sides by 1 minus n by 1 minus n. Then this is really cancelled out, and u derivative over 1 minus n is going to be y the power of negative n times y derivative. Therefore, this one, okay, the first what we have here will be substituted by u derivative over 1 minus n, and the second one here, y the power of 1 minus n will be substituted by u, and everything will be smooth and can be changed to linear first order differential equation. So let us see. This time we are given a Bernoulli's equation. The n is not 1, as you see here. The n is equal to 4. N is equal to 4. Therefore, if n is equal to 4, we can multiply each term by y the power of negative 4. So it's going to be dy by dx means it's y derivative. So y the power of negative 4 times y derivative plus cosine x times y times y the power of negative 4 is going to be y the power of negative 3 is equal to just sine x will be left from the right side, because y the power of negative 4 times y the power of 4 is going to be y the power of 0, because you are going to add the exponent, it's going to be 0. Therefore, this time we need to substitute u is equal to y the power of negative 3. So when you derive both sides, the u derivative will be, the negative 3 will come here, negative 3 y the power of negative 4 times y derivative. By chain rule, we need to derive the y also. Then when you divide both sides by negative 1 over 3, or by negative 3, both sides we need to divide by negative 3. This will be cancelled out. Therefore, y the power of negative 4y derivative is equal to negative 1 over 3 u derivative. Then, now the general equation is going to be changed. The whole, this one, the first term, will be substituted by negative 1 over 3 u derivative. So we can write it 1 over 3 u derivative plus cosine x times u is equal to sine x. Therefore, we can multiply each of the term by negative 3 to remove the negative coefficient, the negative 1 over 3 coefficient, and do u derivative as it is. So it's going to be u derivative minus 3u cos x is equal to negative 3 sine x. This is linear first order differential equation. So we can write this one as du by dx minus 3u cosine of x is equal to negative 3 sine x. Du by dx is the same as u derivative, or dy by dx is the same as y derivative. So don't forget that one at the beginning. Dy by dx is equal to y derivative. So we are completely changed now the given Bernoulli's equation to linear first order differential equation. So this is the way how to change Bernoulli's equation to linear ordinary differential equation. Just one example. In this manner, you can practice and you can have better understanding. Thank you for watching.